Around 5,000 children in England and Wales are treated in hospital with serious burns each year. If a child gets an infection and it is left untreated, it can take longer for the wound to heal, which means more time in hospital and possible lifelong scarring. In severe cases, a burn infection can lead to sepsis, which can kill.
We can look at the burn wound and very occasionally it looks infected, but mostly it doesn't, and we don't have any idea, so we can't take the risk of the child becoming seriously ill. So what we have to do is treat the child with antibiotics and take the often expensive dressings off, clean the wound, which involves pain for the child, possibly an anaesthetic, a trip to the operating theatre, and assume that that wound is infected, when mostly it isn't, but we can't take that risk.
But now, scientists at the University of Bath have created a dressing which warns doctors if a burn is infected. In collaboration with the Healing Foundation Children's Burns Research Centre, based at the Bristol Children's Hospital and the University of Brighton, this prototype glows under UV light if the burn is infected. This would give a clear signal to doctors that the child needs to be treated for an infection.
As bacteria start to colonise a wound, and they form a dense mat called the bacterial biofilm. In this biofilm state, the bacteria are protected from the immune system, but they also start to switch on their production of toxins and of enzymes which break down the host tissue. What our dressing contains are small artificial cells which are broken down by these very same toxins and enzymes. When they're broken down, they release a dye, and this gives a colour change of our dressing from a sort of dull yellow colour to a bright green fluorescent colour.
The team has been awarded £1 million by the Medical Research Council for the next stage of the project, where samples will be taken from real-life wounds and used to test the responsiveness of the dressing.
The aim of this funding scheme is to bridge the gap between the initial proof of concept studies in the lab and the point at which this becomes a real clinical healthcare product that can be used to treat patients.
As far as we are aware, this is the only diagnostic wound dressing that actually detects the toxins and enzymes produced by bacteria. There are other prototype dressings out there which, for example, detect a pH change in acidity or alkalinity of a wound. But these are kind of indirect measurements and are not completely accurate always in diagnosing infection. Where our wound actually detects what bacteria produce, which is a direct signal of change in the pathological state of a wound itself.
It will also help the NHS in reducing costs, which is very important at the current time. If we can diagnose infection early, we may prevent the necessity for children coming to hospital, long stays in hospital, intravenous antibiotics, trips to the operating theatre, and more importantly than that, decrease the possibility of bacterial resistance to antibiotics, which is a global, worldwide problem.